Alright, welcome back. Our next section here, we're going to look at multiplying and dividing, which is also called rationalizing when you're working with radicals. Now, in order to multiply radicals, we have some pretty straightforward rules, and multiplying is very similar to our exponent rules, where you multiply x's with x's and y's with y's when you're doing the exponents. Well, the same thing happens with our radicals when you, instead of x's and y's, have numbers on the outside and numbers on the inside. So when we're multiplying with radicals, all we're going to do is just take the outside numbers and multiply them together, and the inside numbers and multiply them together. The reason we can do that is 3 radical 5 really means 3 times the square root of 5. So really, when you see 3 radical 5 times 2 radical 7, it's really just 4 multiplication problems. And because it's all multiplying, we can change the order around, making it 3 times 2 times radical 5 times 7, which gives us 6 times the square root of 35. So the basics of multiplying are very straightforward. There are going to be times when you multiply that you're going to have to simplify your answer after you've done your multiplication. And I'm going to show you 2 different methods for doing this, because in some problems one method is going to be easier, and another problem you might choose the second method. Whatever you're more comfortable with, they will both work all the time. So if we have this example, 4 radical 20 times negative 2 radical 10, I can do what we did on the previous screen and just multiply the outsides, giving me negative 8, multiply the insides, giving me radical 200. Then I do my factor tree on 200, and I see I have a pair of 5s and a pair of 2s. So I pull the 2 and the 5 out front, and the lonely 2 stays inside. So therefore, my answer becomes negative 80 times the radical 2. Some people like that method. Others prefer to think of it this way. Again, because it's all multiplication, we can do our simplifying before we multiply, so we're working with smaller numbers. And what ends up happening is the 20 and the 10 are going to end up under the same square root. So therefore, we can make pairs when they're not already together. We can still count them as a pair because they're going to end up under the same square root. So we could have done it right away, our factor trees, and now we see our pair of 2s again and our pair of 5s and our lonely 2. We end up with the same factor tree as we would have ended up with in our prime factorization. And then I simply multiply the outsides together, 4 times negative 2 times 2 times 5, and the lonely 2 is still on the inside. So you can do this either way. You can multiply first, then simplify, or you can simplify first, then multiply. So that's it for multiplication. Very straightforward. Outside times outside, inside times inside, and make sure your answers are simplified. For the dividing with radicals we're going to look at in this class, it's mainly going to be what's called rationalizing, is another word that you might say for division. And we just need to remember that a division is the same as a fraction, so when we say we're dividing, we may actually be simplifying a fraction, because that's the same concept. The concept of rationalizing refers to an important rule in radicals, and that rule is that you cannot have an irrational number in the denominator of a fraction. And so therefore we're required to rationalize, or make the bottom be a rational number. So if we look at this example, 6 divided by 5 times the radical 3. In order to simplify this, I need to get that radical 3 out of the bottom. And in order to do that, I can use the concept of multiplying the top and bottom by the same value. And in this case, we would want to multiply the top and bottom by the square root of 3. Because on bottom, when you do the square root of 3 times the square root of 3, we get 3. You've eliminated a radical from the bottom. You've rationalized the denominator. On top, you still have 6 times the square root of 3. And so we have a little bit of simplifying to do, because when I see my bottom, I have 5 times 3. They're both outside of the radical, so I can multiply those together, which gives me 6 radical 3 over 15. And my numbers can still be simplified. 6 over 15 can both be divided by 3, leaving me with 2/5. So we end up with 2 radical 3 over 5. That's what we call rationalizing, which is how we simplify or divide with radicals. So now if we have a situation where we have a radical on both the top and bottom, I'm going to give you two options or two different methods for rationalizing, and you're going to see one ends up being shorter in this case, but that might not always be true. So if you look at our first example here, we have the radical 80 over radical 10. To solve that, I followed the exact same steps I did in the previous problem. I want to get the radical out of the denominator. To eliminate the square root of 10 from the denominator, I multiply both the top and bottom by the square root of 10, because that makes square root of 10 times square root of 10, which is 10. It gives us a whole number value on the bottom. On top, radical 80 times radical 10 is radical 800. Now we have to start into our simplifying steps, and to first simplify, we have to simplify the square root of 800. So you see I've done a factor tree over here, and I end up with two pairs of 2's and a pair of 5's. So I have a 2, and a 5 in front, and the lonely 2 stays inside. So that makes 20 times the square root of 2 divided by 10. And again, I can divide the numbers just like multiplication. When I multiply the insides and I multiply the outsides together, I can do the same rules here. We're dividing, I can divide the outsides. 20 divided by 10 is 2, and the inside stays the square root of 2. So my answer is 2 times the square root of 2. And the downside of this method, as you see here, is we get into some large numbers like the square root of 800 that can be a little bit more difficult. So let's look at this in a different way. If you look at my second work down here, radical 80 divided by radical 10, I can also consider that to be just like our multiplication rule. I can consider that all to be one radical. Radical 80 divided by 10 gets us to radical 8, which is a much nicer number to simplify than the square root of 800, which leaves me with 2 radical 2. So it's the same answer as I got above, only it was a lot fewer steps. So you can recognize this idea. If you have both a radical on the top and bottom and there's no adding and subtracting involved, you can simply treat it as one fraction of 80 over 10, simplify that fraction, then do your rationalizing if necessary. Our final situation today is going to be to look at rationalizing when you have a binomial in the denominator. And I want you to think back to what you did on Friday in your homework when we used imaginary numbers and we had an imaginary number in the denominator. When that was the case, if we had a binomial, we talked about multiplying by the conjugate. And we're going to apply that same concept here today. So if I have a problem such as this, radical 5 over 2 minus radical 3, in order to get that radical out of the bottom, I can't multiply just by the square root of 3 because I have to use the distributive property and multiply everything on bottom by the square root of 3. So that would not eliminate a radical from the denominator. In order to eliminate the radical, I have to multiply by the conjugate, which is 2 plus the radical 3. And what that allows us to do here is, you see the next step, I distributed radical 5 times 2 plus radical 3, which would be 2 radical 5 plus radical 15. And on bottom, I used what we know about the difference of two squares and multiplied 2 times 2 is 4. Our middle term will eliminate itself. And I have negative radical 3 times positive radical 3, which is going to be minus 3. So then I simplify that by simply subtracting the bottom. 4 minus 3 is 1. On top, I cannot put those together, and we'll talk about why tomorrow. But I cannot put those together, which leaves me with 2 radical 5 plus radical 15, because the 1 on bottom is unnecessary.